So we want to know whether or not the data provides convincing evidence that a higher proportion of seniors are going to prom than juniors. And they ask us to use a 5% significance level. So let's start off by, let's do the statistic first. What would I need to do to calculate the statistic? We need p hat 1 minus p hat 2. So what is p hat 1? How would I calculate p hat 1? Oh, sorry, that zoomed way in. Good grief. So 28 out of 50. What is that as a decimal? 0.56. And then we'll do p hat 2. 29 out of 45. And that comes out to be about what as a decimal? You said point what? 0.58. So if I do p hat 1 minus p hat 2, we have 0.56 minus 0.58. If it's not, tell me what it is. I just wrote down the numbers that were given to me. 0.644. Let's go 0.64 then. Say, I'm trusting you guys on this stuff. So 0.56 minus 0.64 would give me what for a p hat 1 minus p hat 2? Negative 0.08. All right, significance level. That's my alpha level. What significance level are we supposed to use? 5%. So 0.05 or 5%. Parameter. What is our parameter here? First of all, how would it start? Before I even write true difference in proportion. P1 minus P2, and then absolutely the true difference in proportion. Yes. Yes, the true difference in proportion of juniors and seniors planning on attending prom. Parentheses, juniors minus seniors. Always make sure to provide your direction. All right, so we have parameter, we have statistic, we have significance level. We still need hypotheses for the state step. So what is my null hypothesis? P1 minus P2 is equal to 0. Make sure this doesn't have hats on it for your hypotheses. The hats are for things that we've actually collected and calculated. This is what is it really, which we think we have a ballpark for what it is really, but we're not sure. And then the alternative hypothesis, P1 minus P2 do it like that? Yes, absolutely. You don't have to do both of those. Yep. We wanted to know, so I want to be really sure that we know where we're getting this information from. It says, do the data provide convincing evidence that a higher proportion of seniors? So I don't just want to know if it's different from. I think more seniors are going to go to prom than juniors. And I have some evidence for that. My p hat 2 is 0.64. My p hat 1 is 0.56. So I have some evidence that it looks like more seniors are going than juniors. So if more seniors are going than juniors, would this be a positive or a negative number? Negative, so less than 0. What is the name of the procedure that we would use here? 2 sample z-test. Yes, 2 sample z-test for P1 minus P2. Nice. I'm going to put something up that has better handwriting. Same information, nicer handwriting though. All right. Now we're all cut up. Just prettier and easy to read, or easier to read than my stuff that was all different sizes and going all over the page. So this particular part here, and it missed part of my equal sign there, I don't know why. That should be equal to, not minus. You do not have to include this part, but sometimes it's a little bit easier to figure out on your direction what that would mean about these 2 populations then. So if the proportions are the same, then their difference is 0. If there are less juniors than seniors, then it's going to come out to be a negative, less than 0. All right, what conditions do we need to check? Random, large counts, 10%. When is the only time we get out of doing 10%? Yeah, if it's not a sample, so if it's an experiment with volunteers, then we don't have to check 10%. All right, do we get random? Yes, how many times do we have to check random? Both times. We have random sample of 50 juniors, random sample of 45 seniors. So teeny tiny words down at the bottom. Checking our other conditions. We said large counts and 10%. Let's do 10% next. There would have to be at least how many juniors? Have to be at least 500 juniors. How many seniors? At least 450. Is that believable coming from a large high school? Yeah. So we're going to assume that we're good on that. When you're checking your 10% condition, something that I definitely want to point out because it is something that they will go after, the first thing you have to write down is the 0.10 or 1/10 of your population. That's what's showing the 10% condition. And then you can go on to multiply both sides by 10 so that you see we would have to have at least how many people. But I do need to see that either 1/10 or 0.10. All right. And then we have large counts. What do we do for large counts? We have to find p hat c. We have to find p hat combined. Does anybody remember how we find p hat combined? Yep, you add fractions the wrong way, the way elementary school kids want to do it. We're going to add our 2 numerators, so we're going to add 28 and 29 together, which gives me 50, you said how much? 57, and then we add our denominators together, that gives me 95. And we get, it's about 0.60. You have to use p hat combined for this. Have to use p hat combined, which is different than confidence intervals. So then we check our large counts with both of these. N1 times p hat combined would be 50 times 0.60. I get 30. That's bigger than 10. We're good. N1 times 1 minus p hat combined, so that'd be 50 times 0.40. That gives me 20. I'm still good. Checking with my second population, 45 times 0.60, 45 times 0.40, I get 27 and 18. All of those are bigger than 10, so we are good. It's big enough to be approximately normal, but small enough that it's not more than 10% of the population. I need it in that sweet spot. All right. So that much of it is like what we did on the check your understanding yesterday. We haven't done the do and conclude part for a difference in proportions yet. And that's what we're getting ready to do now. What's the general formula that we need to use for a significance test for a proportion? This would be the same as what we did on the homework. Statistic minus parameter over standard deviation. That's our standardized test statistic, or z-score. Statistic minus mean divided by standard deviation. So statistic minus parameter. What is the mean? 0. Our null hypothesis was that the proportions were the same, so the mean of their difference would be 0. That is the first question that they ask right here. We assumed the null, so P1 equals P2, so their difference is 0. And we already talked about the general formula. That's down here. Standardized test statistic equals statistic minus parameter divided by standard deviation. So we're going to have to find our standard deviation then. How do we calculate standard deviation when I've got two populations? So super close. And the only thing that's wrong about that, and this isn't something that we've talked about yet, so I didn't expect you to know this, is that because we use p hat combined for our large counts, we use p hat combined for our standard deviation. So you have to find p hat combined. We know our p hat combined was about how much? 0.60. So we're going to have 0.60 times 0.40 over 50 plus 0.60 plus times 0.40 divided by 45. And that's what we will use to find our standard deviation, all underneath the square root. So after you get that written into your notes, I want you guys to actually calculate that for me. Tell me about how big that is. Does anybody have a ballpark for this? 0.1. We're actually going to take it out just a little bit further. This is one where I wouldn't just round to 2 decimal places. So I would go with like 0.1007, just so that I'm capturing that it's not just 0.1. Yes. You could do 0.101, yes. That would absolutely be fine. 0.101 would be fine, or 0.1007. The only reason that I'm taking this one out beyond 3 decimal places is because that last decimal place there, we do start to have a string of numbers then, other than zeros. What should our picture look like? What goes smack dab in the middle? 0. Standard deviation we just calculated. And then what else do I need? We need our z-score, which would be the difference that was actually observed, right? What was the difference that was observed? negative 0.08. So my picture is going to look something like this. Got the mean, standard deviation, both of them marked. It's labeled as a normal curve. And then we have our observed value on there. We do need our z-score. What is the standardized test statistic? What does it mean by standardized test statistic? Z-score, perfect. What is the statistic? What'd you say? Negative 0.08, or p hat 1 minus p hat 2. The parameter is p1 minus p2, and then over that horrible formula for my standard deviation. I like this much better once we start actually putting numbers in there. It doesn't look so bad. Right now it looks horrible. So then we're going to do the do part. What is p hat 1 minus p hat 2? Negative 0.08. P1 minus P2 is assumed to be what? 0. So I have negative 0.08 minus 0 in my numerator. And then we have our standard deviation. 0.1007 for our standard deviation. So we get a z-score of roughly how much? Because these formulas are so cumbersome, especially for two populations, I always calculate them in chunks, and then my last fraction, as soon as I know I've got these other pieces right, my last fraction's not so bad. But I always calculate the standard deviation ahead of time so that I know my denominator and I'm not trying to plug in a gazillion numbers into that denominator. Negative 0.79. I'm going to pop this all up higher on the screen. So that is my test statistic, negative 0.79. Can you guys find the p-value for me? Did you have something you thought is the p-value? It's very close. Yeah. When I did mine, I did 0.2135. If you got 0.23 based on where you rounded, that's still good enough for us to get a conclusion here. How would we start the conclusion? Yes. How do you find the p-value? You do second vars, normal CDF. Do you have your phone? Pull up Desmos. Desmos.com. I can show you how to do it from your phone. You won't be able to use your phone on the AP exam, but I can show you how to do it from your phone. So you're going to do a normal CDF. The lower bound, we shaded over here. So lower bound is like negative 1,000 or 0 even would make sense here since we're talking about proportions, percentages. Upper bound is that negative 0.08. Mean is 0. Standard deviation was 1.007, or at least that's the way I did it. If you did it as 1.01, your p-value is going to be a little bit different than mine, but not horribly so. Okay, so we're going to go to functions. And where are they?
That's tiny.
Yeah. All right, so let's look at all the functions that it gives us. Come on, scroll. I can't see it on here. There's stuff below that, it's just not scrolling down. I can show you how to do it a little bit later, but you can absolutely do it from your phone. Yes. Getting an error. Why is that giving you an error? Oh, I bet I know why. Whoa.
Thank you.
I don't know why your calculator keeps doing that. Okay. There we go. So these calculators are real picky about the difference between a minus sign and a negative sign. So you have to make sure to use the negative. Yes.
Okay, so like, I don't understand why we're doing like the whole big formula. Like, if we found the statistic earlier, and then from this we found the standard deviation, why do we need?
Why
like,
are we finding the z-score?
Yes.
Because that is one of the things that they require on this question.
Okay, so like,
I have no good answers for you beyond that.
Okay.
I wish I had a better answer than that, but they want to see you work out the z-score on this.
And then do I need to like have like, because the only thing in here that's a number is the 1. Like the rest of it is just like the proportions. Like,
Oh, the stuff that you have from earlier?
yes.
Yeah. So do I have to see that entire thing? Not necessarily if I see you do this.
Okay.
I do have to see your standard deviation, so somewhere you have to have like shown how you're getting that number.
Okay.
But those you have up here.
Right.
So that would be fine. Yes.
So you're calculating it, would it look like that? Wait, what's the point?
Let me steal your pencil real quick. So if you were going to write this out, you would do
Wait a minute.
probability, then P1 minus P2 equals 0. Or sorry, not equals 0, equals negative 0.08. Yeah, that's what that would be.
It's because that equation, like,
Mm-hmm.
log down to
Yep.
upper bound.
Yep. How would we start our conclusion here? Assuming the null is true, what was our null? P1 minus P2 is 0. So assuming that's true, what? There's a 0.2135 probability. Yes. Of getting p hat 1 minus p hat 2 of negative 0.08. Or, which way did we shade? Left, so or less. Or less, or lower, or smaller. All right, so that's explaining my p-value. So what conclusion would we reach then? Yes. 0.2135 is greater than 0.05, so we would fail to reject the null, which means we do or do not have convincing evidence. We do not have convincing evidence that a higher proportion of seniors than juniors are planning to go to prom. You guys are getting way better at that conclusion. I'm also noticing that people are getting way better at defining their parameters. versus what we were doing in the last chapter, so good work. Round of applause. Tomorrow, we're going to talk about what it looks like if we conclude wrong. We ran our significance test. I know that I'm not definitely 100% correct, or there's a chance that I didn't get it right. That's what that significance level is saying, right? That's what our confidence intervals have been saying. So if I end up like, I just had this weird sample, and it ended up leading me to a conclusion that's not actually true. What do we do about that?
Get fired.
Not necessarily. I mean, if you do it repeatedly, maybe. But this wouldn't be a matter of a mistake in your calculations. This would be a matter of randomly getting bad data. You collected your sample randomly. You did all the right steps. You followed all the right procedures. But what you concluded in the end wasn't correct. Right. Homework's due on Monday. Homework's due on Monday. Test is on Wednesday.